All right, Costa, you can get started now.
Great, thank you. And good morning, good afternoon, good evening, wherever you're dialing in from today. My name is Costa Makropoulos. I'm with IBM's technology group, specializing in storage. And today we're going to be talking about IBM's capability steps to data resilience. So just to kind of kick things off, the whole idea behind this presentation today is to basically provide a learning experience or a journey or a roadmap, let's say, to cyber and data resilience. So we really want to answer the question, is your business resilient? And the way we're going to answer that question is essentially go through three different things. For starters, we're going to talk about why traditional methods of recovery don't apply to cyber events. The second is, what is data resilience? We're going to define it and why is it important? And lastly, we're going to talk about how to identify gaps in a company's cyber resilience posture, right? So where do we go from here? So to start out, traditional methods of recovery don't apply to cyber events. And it's pretty eye-opening. I mean, I've been in this business a long time now, and it's amazing how many times I'll talk to a customer and we'll be talking about disaster recovery, business continuity, and they'll say, yeah, I'm good to go. I'll use that same infrastructure for cyber recovery. And I kind of want to highlight here the differences between disaster recovery, or what we historically refer to as business continuity, and cyber recovery. Because while some of the infrastructure may be shared between the two, the concepts, the processes, the documentation, and the way to recover is really completely different. So let's dive a little bit deeper into this. So in a disaster recovery mode, we generally know what happened, when it happened, and the nature of the disaster. So I'll give you an example. In Toronto about a month ago, we had some serious flooding happen in the downtown core. I had some customers had their data centers flood. So that is a known point in time. The customer knew exactly what happened. It was a flood. What was impacted in terms of infrastructure, applications, and things like that. They knew how far the impact spread, and they knew exactly what to recover and when to recover it and what version to go back. Now, if we look at a cyber recovery, it's, to be honest, the complete opposite. You don't know how long the bad guys have been in the environment. You don't know how far spread um, the data corruption or encryption or data losses has gone. We don't know when it happened. We don't know what we have to recover. We don't know what version to recover. So trying to leverage the same types of solutions that we did for disaster recovery, for example, 2 sites, similar infrastructure, replicated copies of the data that look identical, doesn't really work for cyber recovery. And the perfect example is, your primary data center or primary location gets hit with ransomware, and you replicate all your data from site A to site B. Well, guess what just happened? You replicated that ransomware, that malware, that encryption to that secondary site. So now both copies are encrypted or targeted, right? So I want everyone to kind of keep that in mind, because that's really the foundation or the basis of everything we're going to be talking about here. We're going to be defining what data resilience is, and data resilience solutions really need to cover both aspects, right? We're not saying that everything you've invested in disaster recovery and business continuity gets thrown out the window. No, it's still required, it's still needed, but it's solving a different problem. By the way, if anyone has any questions as we go along, I believe we do have folks, and thank you to my extended IBM team that's in the meeting here with us. They'll be able to highlight whenever questions pop up in the chat. So feel free to type in questions in the chat, and we'll break away and we'll answer those for you. So by all means, take advantage of the chat window. Okay, so now that we know that cyber recovery is different than disaster recovery and why, let's define what data resilient solutions are. So a lot of the things that we do at IBM leverages industry standard agnostic tool sets, right, and frameworks. So a lot of what we do in cyber, whether it's on the cyber security side or on the cyber resilience side or data protection side, relies on the NIST Cyber Security Framework. I apologize. This is actually the older picture of the NIST framework. The NIST framework, if you're familiar with it, did get revised this year to the NIST 2.0 framework, which includes a sixth pillar entitled governance. But essentially what we're doing is we're looking at industry best practices, completely vendor agnostic. In fact, we don't really talk about specific vendor technologies. When we're talking about is your business resilient, we look at two things. One, from a data security standpoint, using the NIST framework, data security is all about having tools to prevent attacks. So how do I keep the bad actors out of my environment? But it really does nothing to help in the recovery process. Now, if we look at it from the other way around, historical, kind of where the storage brands fall in and infrastructure, data protection is the opposite, right? It's the reactionary process. It's all about how do I get back up and running after a disaster, or in the case of cyber, after an attack has hit, but it does nothing to help avoid the attack. And what data resiliency is leveraging these two together, fulfilling the NIST framework. So how do I both prevent bad actors from infiltrating the environment, and also in the unlikely event that it happens, how do I get my business back up and running? And what we're starting to see, particularly in the last couple of years, is that security and infrastructure teams are starting to work closer together. And we're starting to see that from vendors in terms of the products that they're bringing to the marketplace today. So for example, you'll see a lot of security tools now being able to help orchestrate a recovery. We're starting to see a lot of storage infrastructure tools being able to be more proactive in terms of preventing threats, whether it be anomaly detection or other things. So the better we can get as an industry, and the better we can get from your perspective as your two teams who are traditionally siloed, your security and your infrastructure teams, the better we can get at communicating and working together, that's how we build data resiliency. So I mentioned at the beginning, this is kind of a journey. So we like to refer to it as the steps to data resilience. Right? From a steps perspective, everyone will be on a different layer depending on their cyber resilience maturity or their cyber resilience posture. So what I really want to focus on are what are these steps and what are the key assets and the key tools that we can leverage in each one of these steps to get a little bit better. Right? Everyone will be on a different journey here. Everyone has some type of foundational capability. And by foundational capability, we're looking at the far left of your screen here, the security and data protection. Right? So if your mandate is infrastructure or security, you already have tools in place to be able to do this kind of stuff, right? So you'll have some form of data security software in place, data classification, understanding what you have, how to protect it, and how to get back up and running. The second phase, and of course we assume everyone's covered in that first phase, right? Everyone has some form of security tool to help you understand if someone's trying to break in, and everybody has some form of data protection to be able to have a copy to recover from. The second piece, or elevating that next step to the second level, is something that the industry refers to as immutability. So it's one thing to say that I have multiple copies of my data, and they could be for versioning purposes, for recovery purposes, but immutability takes that up one extra notch. Essentially what that means is the copy that you have is incorruptible. Data cannot be altered, cannot be deleted. It's kind of frozen in that point in time. And what we've been starting to see over the last few years is when the bad actors infiltrate an environment, the first thing they're going after is the backup data, that secondary copy of data. Because what's the first thing as infrastructure administrators or folks that are involved in responding and recovering to an attack, the first thing we do is, okay, my production is down, let me go find a backup. And historically, we leverage solutions for backup technology to be able to back up a certain amount of data, incremental data change in a certain time frame window. Right? And it was generally for things like a fat finger delete, needing a previous version of a file, or maybe for some form of disaster recovery. But now what's happening is the bad actors are infiltrating the backup environment. They're corrupting the data. They're encrypting the data. They're deleting the backups entirely. So they're taking away that first method of being able to respond and recover in the event of an attack. What immutability does is it essentially locks down that copy and prevents someone, even someone internally, from deleting that copy or altering it. Therefore, the malware cannot infiltrate it. The encryption cannot infiltrate it. And, I can go back 40, 50, now 60 years at IBM, where we've been a pioneer of immutability on the storage standpoint. We think of tape technology. That really was the first ever, immutable or air gap type solution. Why? You wrote your data to tape, you remove the tape cartridge from a library, you put it on a shelf. Well, guess what it means when it's on a shelf? It cannot be altered, it cannot be deleted, it cannot be corrupted because it's physically disconnected from the network, physically removed from an array. So there's two types of ways you can do immutability. One can be physical and the other is logical. The tape example is obviously physical. I am removing that device, removing the data from the library, putting it on a shelf. It cannot be accessed. And the second being a logical air gap, meaning I've put parameters around that copy of data which prevent logical corruption of that data. Users cannot access it. Users can't delete it. So that's kind of the second level of data resilience when we're looking at steps. And we're seeing more and more customers start to adopt these forms of immutability, whether it's going to be on production data or on backup data, as that layer of defense, knowing that bad actors will be going after it. We look at the third layer or third step in terms of data resilience, and this is the discovery phase. And this is where we want to look at two things. We want to understand what are the active threats, what's actively going out in my environment that could penetrate the environment and insert malware, ransomware. But then also, how do I find and prevent dormant threats? And really, you're looking at using two different tools to do this discovery. On the one end, I want to be able to understand as data is being written to the environment, is this data clean? Is someone trying to do bad things? And then the other is more of a deep reactive scan to say, crawl my file system, crawl my backup data, and try to understand, have there been any dormant threats? And so discovery is a key thing here. And this is one of the instances where security tools and infrastructure tools are starting to work more closely in line with each other. Right? The fourth step is recovery. And really there's two types of recovery here. There's the rapid operational recovery. So how do I get my mission critical workloads, my crown jewels, the most important critical data of my environment back up and running, whether that's in seconds, minutes, or hours. And then there's the everything else, right, which could take, a few days potentially. So that's the recovery phase of this. And we kind of wrap this all together from a steps to data resilience standpoint with automation. So all of these tools, all these technologies are great, but if I have to go out and hire 3, 4, 5 more folks to manage that environment, to understand what's going on, to keep eyes on the situation, well, that's just not feasible in today's day and age, right? I like to refer to something I call human virtualization, which is essentially everyone's wearing multiple hats these days, so they don't have time to be able to take on additional responsibilities. But what if there was a way that we could leverage automation tools and orchestration tools to be able to do all of these steps, and then with the click of a button, orchestrate a clean room environment, orchestrate a recovery, understand if this happens, then that. So this automation and orchestration is really what ties everything together here. And again, just a reminder for everyone, if you have any questions, you can feel free to put them in the chat. I'm not sure, Heather, or anyone on the team, if there's any questions in the queue right now. No? Okay. So we'll move on to the next step here, and that's essentially how do we dive deeper into these five steps to data resilience? So we talked a bit about the cybersecurity tools and integration between tools that help keep the bad guys out and tools that help respond and recover. And there are a number of tools from the IBM portfolio that allow us to do this. There are also third-party tools, obviously, out there. One of the key differentiators from an IBM perspective is our ability to integrate not only with our own stuff, but integrate with third-party tools. There's no single vendor that can come out and say that they have the complete be-all and end-all solution in every single product to grab every piece of the puzzle. You know, data resiliency, cyber resiliency really is a team sport. So we'll work with the Palo Altos of the world, the Arctic Wolves of the world, SIM tools that may or may not be IBM branded. But the idea here is how do I have the hooks to tie these things in together? Again, from a foundational aspect, it's really important to understand what do I have and what the importance to my business is. So data classification is really the first step here. And data classification doesn't need to be overthought. You either have absolute mission critical, needs to be back up and running really fast data, and then you have everything else. I can't tell you how many times I talk to customers where they'll provide a list of all of their applications and they'll have them tiered into 5 or 7 or 10 different tiers of applications. At the end of the day, if something bad happens, who needs to be back up and running first? So part of the data classification process isn't just understanding what applications you have and their importance to the business, but also from a documentation standpoint, how good is your documentation when it comes to cyber recovery? Everyone's pretty good at doing a once a year disaster recovery test where they've got a playbook listed out. These are the applications that we're going to be bringing up first and testing in our DR plan. We're going to do this once a year, and that's great. And that's great for that one use case. But what about the use case of cyber attack where you don't know what's clean, you don't know what's infected? So having a separate incident response plan document is key here. And from a data classification standpoint, again, it's mission critical, meaning it serves my customers, it brings money into the organization, it pays the bills versus everything else. Now, we didn't set up this webinar to do any polling questions, but I do want to throw out a few statistics here rather than ask the question and try to get responses back. But if you were to guess at how long the average time it takes to respond and recover from a cyber attack, would you think it would be a day, a week, a month? Right? So IBM does a lot of research. We do a lot of CIO reports. In fact, we commission a report to be run every year called the cost of a data breach. And as of the 2023 data, we have the average time it takes to respond and recover from a cyber attack is 23 days. Now think about that for a second. Look at your business internally and think, if it takes me 23 days to get back up and running in a somewhat usable format, what does that mean to my business? Can my business survive being down and out for 23 days? And unfortunately, we just have to look in the news. It seems every month another Canadian company is being hit with some type of cyber attack, costing millions of dollars, taking weeks to respond and recover. So think about that for a moment here and say, what are the workloads from a classification standpoint that I need to get back up and running in 2 to 3 hours, not 23 days, not even 2 or 3 days. And that will help with the data classification aspect of it. The second piece I want to mention here, so we know it takes on average 23 days to respond and recover. The second piece is, what is that cost of a data breach? Right? So IBM's cost of a data breach analysis, which is publicly available, you can look for it on the IBM website, and I encourage you to download it because we actually break down the cost of a data breach not only between geographies, so Canada being a geo, but also within specific industries. And if you wanted to know what is the average cost of a data breach, $1 million, is it $5 million, is it $10 million? That number for 2023, which is in the 2024 report, is an average of $6.4 million Canadian. So now I put those two together and say the average time it takes to respond and recover is 23 days. The average cost is $6.4 million. What am I doing internally to ensure that I can be faster than 23 days and less than a $6 million hit? And it all starts with the data classification, the cybersecurity tools, and the data protection tools. I mentioned before from an immutability standpoint, how we're going to elevate those copies and ensure that they cannot be altered, cannot be deleted. 7 of those 23 days that it takes to respond and recover on average is spent trying to find a clean copy. Think about that. Let that sink in for a second. An entire week goes by trying to find a clean copy. Why? Because we don't have the tools in place from a discovery standpoint to understand just having a copy isn't good enough. So being more proactive in our scanning, trying to detect anomalies as they occur rather than when they're dormant. And this is what allows us to shrink the window of time from 23 days, take an entire week off of that, because we can find from an anomaly detection standpoint or a data integrity standpoint, we can find the copy of data that we can actually use to restore from much, much faster. Right? So if you were to take anything away from what we're talking about here today, think data resilience is all about time. The time to recover can be shrunken, and the faster you can recover to a clean environment, the less it's going to cost in terms of the data breach overall cost. So creating that data isolation, that physical or logical air gap is that first step. So ensuring that the copies that I have couldn't have been infected after the fact. But then proactively looking at those copies of the data, whether it's for malware scanning, testing, leveraging machine learning and AI technologies to, scan deeply into the file system to understand if there's any dormant threats. From an IBM perspective, we do both. So we'll do anomaly detection and scanning directly on the primary storage array as data is being written. Think about that for a second. Most tools that we have running today are reactive tools, a post-process tool that scans the data not only after it's been written and read from, but it actually scans it on the backup copy. IBM's doing that, but we're also doing it from a primary storage array. Every single write that is written to that storage array is scanned for an anomaly detection. And we're not just scanning it on one parameter. There's over 30 different parameters that we're looking at as data is being written the first time and through its entire life cycle. Has the data been encrypted? Is there an increase in writes? Is the compressibility or data reduction down? 30 different capabilities or 30 different ways that we're looking at the data to detect anomalies as they occur. The faster I can detect them, the faster I can minimize that blast radius, how far it goes. So we're starting to see more and more people adopt these types of tools to be able to understand if the threat's coming, I can find it faster. If the threat's already in, I can contain it faster. From a recoverability standpoint, this now ties back into this whole idea of data classification, where I have my minimally viable company, which is all of the mission critical workloads, the first things that have to get back up and running. When you look at your incident response document, these are the first, 5 or 10. In most cases in the customer environment, this would be, 10 to 15% of your data tends to be that mission critical stuff. So that minimally viable company, I want to be able to recover super fast, which means I don't want to have to go to a backup copy that may be sitting on tape or sitting somewhere out in the cloud that I have to rehydrate fully to be able to restore from, that I need to run analysis tools. That could take days, that could take a week, right? I need to be able to get my minimally viable company back up and running super fast. So from an immutability standpoint, that means I'm going to be pulling a copy off of the primary array that's immutable. From an anomaly detection standpoint, that means I'm going to leverage the anomaly capabilities or the anomaly detection tools of that primary storage array. Why? So I can get that data back up and running in 2 to 3 hours, not two to 3 days or 23 days. Now, for the rest of the stuff, the 80% of the data that's not mission critical, I can afford to put that on secondary storage, scan that more reactively, maybe once a day, once a week, versus every single write. That will be put on lower cost infrastructure, more meant for long-term retention off of the primary array, but I can afford for that to be 2 or 3 days to get back up and running. So now you see this difference between how data classification works and how I can understand what needs to be back up and running fast, and then everything else within the environment. Now, from the standpoint of how do I orchestrate all of this recovery, we then look at the orchestration or automation tools to basically streamline or simplify responding and recovering. So I mentioned at the beginning, everyone tends to have some type of cybersecurity tool. Then there's the orchestration piece. So the SOAR tools, the orchestration that will essentially say, let me holistically look at my entire environment and say, okay, these particular 5 applications are going to be my minimally viable company. I want to create policies and structure around that to say, every day I want to take an immutable copy on my primary array for that data, and I'll keep it there for 7 days. For ultra fast restore, what am I gaining again? Time. Gaining time to be able to get back up and running really, really fast. Now, again, from an orchestration standpoint, everything else is still being backed up every single day, and I'll have whatever my retention policy is for that. And then I want to take it one step further. Now that I've created these copies and they're immutable, the next step would be implementing something called an isolated recovery environment. You may hear that referred to as a clean room environment. So just having the copies isn't good enough. You need to be able to scan those copies periodically to ensure that they are in fact clean. Right? So I could have 30 versions, 90 versions of my backups, but if they're all infected, they're all equally as useless. Right? So creating some form of isolated recovery environment where I can periodically take one of those immutable copies, mount it into that clean room, run forensic analysis, scan the data, ensure that it is in fact a clean copy, not just a copy, but a clean copy that I could then use for the purposes of restoration. Remember when I mentioned before, it takes on average 7 days just to find a clean copy. If you implement something like a clean room type environment or an isolated recovery environment, again, you don't want to be re-injecting your production environment with potential malware. You really want to segregate off pieces of infrastructure, a server, a piece of storage, your backup environment, isolated network to be able to run in that clean room, to run forensic analysis tools on it, but do it proactively rather than reactively. So every day I take a copy, every night I scan that copy. And with the orchestration piece, you can do all of this in an iterative fashion so that you're not adding more resource and more workload to the folks on your team that are already too busy enough to be able to handle this. Right, so some of the other tools that you can leverage and use here, IBM acquired Red Hat now 5 years ago. Part of the Red Hat acquisition was a tool or a company called Ansible. If you're not familiar with tools like Ansible and another IBM acquisition, HashiCorp, which makes Terraform, these are orchestration and automation tools that can allow you to create these types of playbooks to be able to orchestrate this type of a solution. Again, the more you practice, the better you get. So that more often that I can scan the data, knowing that it's clean and not just a copy, the quicker you're going to be at recovery. Quicker meaning saving time. Time is money. I can get back up and running faster. We're also starting to see a lot of government legislation in this area. So depending on where you are in the country, you may already be subject to some of these new government initiatives to essentially say you have to disclose if you have been breached, you have to provide certain tools and be able to recover certain pieces of information within a timely manner. We're all familiar with the concepts of a recovery time objective and a recovery point objective. But we understand those in the context of disaster recovery. And if we rewind back to the beginning of this presentation, I mentioned that disaster recovery and cyber recovery are completely different processes. When was the last time you looked internally into your company and said, what is our recovery point objective for these mission critical, minimally viable applications? What is our recovery point objective and recovery time objective? Not for a disaster, but for cyber. Remember, when we're talking about business continuity and disaster recovery, the primary assumption is that second copy that I have replicated at my DR site at a colo facility. The primary objective or the assumption is you know that that data is clean. Well, what's the biggest problem in cyber recovery? The biggest difference is you don't know what's clean. So really, when we're looking at recovery point objectives and recovery time objectives, we have to look at them from both lenses. From a disaster recovery, I may be able to get away with a 4-hour recovery point objective. Is that reasonable or even capable to be done from a cyber attack standpoint? So if there's one takeaway from this page here to remember is this doesn't have to be an all or nothing thing. The idea is, where am I today? Where do I want to go? And what are the steps that I need to do to get there? Right? Because there's no way to do all of this. There's no magic one button, one product that will do all of this. Now, from an IBM perspective, we like to refer to this as IBM Storage Defender. Right? So these are a series of capabilities that provide all of these functions that you can turn on and integrate with the tools that you have in place today to be able to get back up and running when you need to. Now I'll pause again. Heather, any questions in the chat?
We don't have any questions in the chat, but Chad did link the cost of a data breach report. So that
Perfect.
is sitting in the chat now.
Yep. Thanks, Chad, for doing that. It's a really good read, not just if you're trying to go to bed at night. It might actually keep you up at night once you start reading all of the information in there. But it really is a wealth of information. One of the benefits of working for IBM is we have a huge team whose job is to do this kind of stuff. In fact, we have, if you didn't know, an X-Force team. If you ever were in a situation where you got hit with some type of cyber attack, there's a 1-800 number that you can call, and IBM can be brought in on a retainer to be able to help get you back up and running, which is yet another key message here that I want to get across. Documentation is very important. Being able to understand what needs to be done in what order and how I'm going to test, because that's different than the disaster recovery document. The other thing to keep in mind, one of the other reasons why it takes 23 days on average to respond and recover is people and burnout of employees. So employee burnout, think about it. If you got hit with some type of cyber attack, and I truly hope that none of you on the phone today have been involved, because the folks in the room with me and the IBM Markham office here have been intimately involved in helping customers respond and recover to cyber attacks. And I shouldn't be joking, but burnout is a problem, right? You have limited staff. You could have all the documentation in the world, but the human element, the human error element is real. The longer you're working, the more stress you have, the higher the probability of making a mistake. So leverage resellers, leverage consulting firms, leverage cyber insurance firms, whoever it is, anyone you can get on a retainer that can help you get back up and running, because eventually the staff that you have are going to get burnt out and they're not going to be able to do their jobs effectively. Right, so another thing to keep in mind now, if we have the orchestration tools in place where I can click a few buttons and then just monitor the processes, if I have a global dashboard view, which the IBM Storage Defender does, to be able to say, hey, there's an anomaly I detect, hey, there's a malware scan that I detect, something somewhere where I can see holistically what's going on, integrate that into my security operations center that I may already have, integrate that with a network operations center. Now you get to see where this holistic view, where security teams and infrastructure teams are working together to get back up and running. Now, It's at this point where people tend to ask me, okay, Costa, how do I know where my company is in this step to data resilience? I see a lot of words on this chart. I see a lot of steps. How do I know where to start? And that's where we have an offer for those who attended today. Thank you for attending. IBM has funded a secure and resilient assessment. And essentially, the goal of this assessment is to work with our clients to understand from the NIST Cyber Security Framework methodology, what are you doing well and what are some of the gaps that you may have? Right, so we look at it and say, okay, the NIST Cybersecurity Framework in the 1.0 version had 5 pillars. Let's ask a series of questions in the identify phase. So understanding, do I know what I have and its importance to the business? Right. And we'll do this as either a sit down, in a boardroom. We'll get the infrastructure folks, we'll get the security folks, we'll get the backup admins, storage people, all in a room, and we'll ask a series of questions. It's a 2-hour virtual consulting workshop, so very low touch from your perspective. There's no agents or tools that you have to install to crawl your environment. This is not meant to be a pen test or a threat detection exercise. It is an assessment that's based on a questionnaire. And the way we ask the questions, we essentially expect either a yes, no, or a maybe answer. So when you have 5, 6, 8 folks in a room and you ask a question, for example, do you practice recoveries assuming a mass restore or assuming that you've been corrupted versus disaster recovery? You may have one person in the room say yes, and another person says no, and we sit back and watch the fireworks and try to figure out what the real answer is. And the benefit isn't necessarily getting the yes or no. It's to highlight what you're doing well and where some of those blind spots and maybe some of the gaps and recommendations would come across. So across all 5 of the NIST cybersecurity framework pillars, now the 6th one, including governance, which talks a lot about things we hate to talk about, right? Documentation and governance and ensuring that we have proper processes in place to be able to get back up and running. We ask these questions. This is IBM funded, but it is not an IBM branded product solution, if I'm even wording this right. So essentially what happens is all these questions are based on the NIST cybersecurity framework. There is no mention of IBM products in the questions that we answer. There may be some reference to technologies in the deliverable after the fact. It takes 2 hours to do. Essentially what will happen is we'll have the initial conversation, probably about 15-minute exercise, just to make sure we know who the right folks are to invite to the meeting so that we're going to get the answers that we need. Then we have the typical 2-hour workshop itself. About a week to 2 weeks later, depending on how busy we are, we'll then present our findings with a final report, presentation, and roadmap. That is a roughly 10-page PDF. You'll see some screenshots on your screen here. Kind of give you a spider webs view on the things you're doing well, maturity scores on each of the 5 pillars, as well as a final overall score. Now again, the score itself, the number is not what's important here. What's important is to understand what am I doing well and where are some of the gaps? And those gaps will help you increase your cyber resiliency posture and get you up those levels or those stairs of data resiliency. Right? That 10-page PDF is then considered, IBM and confidential with you, the client. We don't share that data. Obviously, if CDW is involved, we'll invite CDW with us on that call to understand, because in a lot of cases, some of the outcomes of this document will point to non-IBM products that can help you reach those goals. And that's where, someone like a CDW can help you if, IBM isn't the right piece for this one gap that you may have. Right. So I encourage all of you to invest in doing one of these. It's around this time where I typically get a question in the chat saying, I've done one of these before with my cyber insurer. How is this different? Do I need to do another one? And to that question, I typically answer, great. What did you do about the outcome? Because it's really the outcome that really matters. So if there was a recommendation to do 5 things, for example, turn on immutability on your backups, create a clean room environment, test for ransomware mass restores rather than DR. Did you do any of them? Did you assign an action plan to it? Do you have a project timeline when you think you want to be able to do these things? You don't have to do multiple assessments to be able to come up with these same answers. In fact, we have, seeing as though we've done probably 450 to 500 of these assessments over the last couple of years, we have the list of the top 5 things that we run into over and over and over again. Because the reality is, it doesn't matter what industry you're in, whether you're small or large or a medium-sized firm, when it comes to cyber recovery, everyone seems to be hitting the same gaps and the same issues, right? Because the solutions that we put in place might have been put in place 10 years, 15, 20 years ago, where we were trying to solve a different problem. And with that, I'm picking on something as simple as backup. The problem we were trying to solve and architect around 20 years ago was, how do I recover from a fat finger delete, from deleting a single machine, a single file, a single VM? We did not architect to try and recover an entire data center worth of corrupted data that may have been corrupted for a week. We were architecting for something completely different. And therefore, the processes, the tools, everything we need to use have changed in those last 20 years. So leverage something that is industry standard, like the NIST Cyber Security Framework, understand the scoring within the 5 different pillars, and then leverage that document, that 10-page PDF output, to build a project plan around some of those gaps and say, hey, here's the 10 recommendations that the IBM and CDW team came up with on this assessment. And we're going to tackle, 1, 3, and 5 next year. We're going to do 2, 4, and 7 the year after, and we're going to do 8 and 10, 3 years from now. So it really builds a nice, easy to digest and understand document with a plan that you can tie a roadmap to and say, this is how I'm going to go back to the senior executive team and say, I need budget to do this next year. I need budget to do that the year after, to ensure that my data resiliency posture is raised. Sometimes we'll even do one of these assessments with a client and then come back a year later and do the assessment again and say, hey, what was the difference in your score? What have you done in that year since we last did this? And it's all about getting better, and practicing is a way to get better. So doing a once a year DR test, I'm sorry, that's not good enough anymore, right? Doing a 4 times a year disaster recovery test that involves, the potential for a mass restore to simulate a cyber attack. That's where we need to get to. And then eventually, if we're doing some of this orchestration and automation, we're not even really doing the testing once a year or 4 times a year. It's an iterative process, and we're constantly testing. And that's really what we want to get to, but it's baby steps. On that note, that was the last chart that I wanted to go over with today. So again, as a reminder, the 3 things we learned today were why disaster recovery and cyber recovery are different, right? We learned what data resilience is, how to define it, and why it's important. We learned about the 5 capabilities or steps to data resiliency. And then we also learned how to understand and how to find some of the gaps in our cyber resiliency posture by leveraging a tool like this IBM-funded Secure and Resilient Assessment. On that note, I'll ask Heather one more time if there's any questions in the Q&A. Feel free, if you're a little too shy to put your questions in the chat, you can always reach out to the CDW team, your account exec, and pose the question there. They'll pass it on to us, and we can engage directly on a phone call or even come out and meet you if you wanted to dive deeper in any of these things.
Good news, there is a question.
Okay.
it's will the presentation be shared afterwards? And the answer to that is yes.
Yes.
I believe the presentation is going to be sent out with a short survey. And if you do complete the survey, I believe we have a Java card that we will be sending you. But yes, for sure, the presentation will be sent out. Please reach out to your CDW rep who will engage us to have a conversation if you have further questions and aren't comfortable asking it here. We can also take questions in the chat. I'm not sure if you guys are able to come off of mute and ask questions live, but feel free if that isn't a possibility, or we can also do it in the chat.
I think there is another question is, can I see an example of one of these assessments with customer data scrubbed? So yes, we do have a sample output of the 10-page PDF if you kind of want to see what the format would look like with fictitious customer information, obviously. But we do have the sample, so not like more than just these 2 screenshots. You can actually see what a real sample was without any customer real customer data in it. Right. A lot of times people will use that to go back to their senior management team and say, hey, I want to get, these 5 folks in a room. Can you push the agenda down so that we can do it? And here's an example of what the output would look like, but with our data in it. Okay. On that note, if there aren't any other questions, again, thank you from Team IBM here. Thank you for joining. And don't forget to look out for the email with a copy of the presentation and the survey to get the Java card.